Hello, my name is Brock Lemires and I will be your instructor this summer for EELE 371, Introduction to Microprocessor, Hardware, and Software. We also call this course Embedded Systems Design, which is probably a little bit more accurate, but we'll use the two interchangeably. In this video, I want to go over the logistics of the course, talk about how you log in, what you're going to be doing for assignments, how you're going to read and watch video, or read the book and watch videos, and how you actually are going to turn in the things that you'll be graded on. Before that, though, I'll give you an overview of why we take this course, why it exists, and then also a overview of myself and my background as the author of the book, the teacher, and also the voice and hands that you'll be seeing in the videos. So let's take a look at what this course is all about. So we are going to learn about computers. And so this class really is meant to give you a deeper understanding of the components in a computer and how they were used. But when we do it from a kind of a hardware or a level where the computer is already in front of us, what we're trying to do is we're trying to learn about a common architecture, and then we understand it more by programming it at a very low level. So we want to like write instructions for the computer and watch information move back and forth between memory and the CPU. Look at how things are manipulated. Look at how memory is allocated. And so we're trying to form an understanding of a computer. And this architecture that we learn is relevant to all computers. And so if you think about general purpose computers, laptops and workstations and servers, they all have the same general architecture. They have a central processing unit. They have program memory that holds your program. They have data memory, and they have I/O. And they all execute code in a very similar way. And so if we develop an understanding of just any type of computer, it applies to all computers. But in this class, what we do is we specifically start by looking at what we call embedded computers, also called microcontrollers. And these are the computers that you find them everywhere. These are the ubiquitous computers. So these are the ones in like your car and in your TVs and in thermostats and stuff like that. And the reason we do that is has many reasons. Number one, these type of computers are inexpensive. And so we can have a computer that sits in front of us, and that's what you're going to do, that we can actually program and actually watch it operate. And it doesn't cost, $1,000, right? We can spend $10 and have a little computer in front of us. And these computers, not only is that a good way to learn the architecture, which extends over to general purpose computers, but then we also get to learn about the type of embedded computers that are in everything, because there's more of these than there are of the general purpose. And so we actually look at this thing, they tend to call them microcontrollers because they're little computers that are embedded in a system that control things. And so what's unique about microcontrollers versus a general purpose computer is that it has a lot of peripherals such as analog to digital converters, serial peripherals, and a bunch of common interface peripherals that allow you to interact with the external world. So when you get done with this, what's cool about it is, number one, you learned about what a computer is. Number two, you learned how to program a computer. That's a good skill. And then number three, you learned about embedded computers and microcontrollers, which are the most commonly used computer anyway in the world. And so you have a really practical skill. Okay, so then here's how we're going to do it. We're going to march through 15 modules. This is a lot of modules. We're going to cover the entire textbook, but not all the modules are created equal. Okay, some are very short. Some of them are very long, and so don't worry, they're not evenly distributed, so don't worry about going, holy cow, 15 chapters. So for example, module 1, it's only a couple pages long, and it's just to give you an introduction to what an embedded systems is and an embedded computer. Module 2 is going to be a digital logic basics. Now, this one, I want to warn you right away, you were supposed to have a prereq of digital logic circuits, okay? And so chapter 2 is massive, but it's supposed to be a review. So the way that you're going to approach module 2 is I would suggest going and just opening the homework assignments and then looking at what they're asking. And then if you don't remember anything, go ahead and access the resources I provide to you. But when you open the book and you look at chapter 2, you're like, holy cow, that's a whole course. And the reason it is big and it looks like a whole course, because it is a whole course. You're supposed to have taken that already. Okay. Then we're going to do module 3, which is just looking at the overview of a general computer and definitions and terminology. And then we get into module 4, which is where we look at the little computer board that we're going to have. So this is the specific microcontroller called the MSP430. and we're going to use the MSP430 FR2355 on this Launchpad board. And so this red board is what you're going to have plugged into your computer while you watch the videos and read, and you're going to type in example code and watch stuff, watch LEDs flash and do all this cool stuff. And then this is what you'll perform your lab on. Since we're going to actually be programming it, we have to start looking at how do we program. And we're going to start in Module 5 in a very low-level language, which is called assembly. Assembly is almost a one-to-one mapping of a line of code, a statement of code is an actual instruction that this microcontroller can execute. Very simple things like move information here, add in these two pieces of information, invert this word. So it's very low level. And guess what? It's a skill. So there's times in your career where you may need to program in assembly because it gives you very low level control of the hardware. All right, and then we can go through, since we know how to, or as we're learning in assembly, we move through the three main categories of instructions, which is data movement, data manipulation, and program flow. And again, these three classes are implemented in all computer systems when you get down to the low level. Then we get to start looking at some peripherals, and so we start accessing the outside world. So Module 9, we're going to look at the parallel I/O system, which we just call digital I/O, and that's how you get information in and out of the system, of the microcontroller. Then we go and we look at the stack and the subroutines, which is how do you actually implement subroutines in a real computer, and then how do you dynamically allocate memory, which is using the stack. And then we look at interrupts in detail, and so all this is in assembly. And then we look at timers, and this is a very powerful peripheral that allows you to track time independent of the CPU operation. And we're still just doing this all in assembly, and it's low level, and we understand all the bits that we're banging. And then Module 13, we stop for a second, and we switch to C. So more than likely, if you program microcontrollers, you're going to be doing it in C. So what we do is once we have a basic understanding of what a computer is and how a microcontroller works and how peripherals work, then we switch over to C and we remind ourselves what C does, and then we actually implement everything that we've done up until this point in C. And you see how quickly you can actually implement these at a higher level language. And then that takes us into the final two peripherals, which are the most complex that we'll cover, which is number one, the serial communication peripheral, and then the analog to digital converter. So before we get into the logistics of the class, you must be wondering, well, who is this guy who's going to be teaching me? So I am a professor of electrical and computer engineer at Montana State University. So I am physically located in Bozeman, Montana. And I got my bachelor's degree from Montana State back in the 90s. And then I went to work for Hewlett Packard, where I designed electronic test equipment for 8 years. And I was a digital hardware designer. So I did FPGA design, printed circuit board design, acquisition system design. And so all of the circuitry that I'm going to be teaching you about is stuff that I actually use as an engineer in industry. And so this stuff is real. It's not just make-believe. You will actually use this stuff. And so while I was working at Hewlett Packard, I decided to go to graduate school. So I went to, I got my master's degree at the University of Colorado in Colorado Springs. And then after that, I started teaching as an adjunct instructor, classes on embedded systems at University of Colorado in Colorado Springs. And after a couple of years of that, I decided that I really liked teaching and I really liked being an electrical engineer and a computer engineer. So I decided to go back to school and get my PhD. And so then I continued working and going to school, but this time I was going to school at the main campus at University of Colorado in Boulder. And so then after years went by and I ended up getting my PhD, and that allowed me to become a professor. So in 2006, I came back to Montana State, and I have been a professor now for nearly 15 years. And what I do is I teach and do research in the broad area of computer engineering and digital systems. And so I'm showing you my website right here just to kind of highlight some of the things that I do. So the classes that I teach are like introduction to logic circuits, obviously, both at the very low level all the way up to senior and graduate level, digital system design and high-speed digital system design. And then I do research on, using embedded systems to solve problems and also coming up with novel computer architectures for various applications. So my main work, if I come out to my research over here, My main work has centered around trying to exploit these programmable logic devices to create real-time adapting hardware that can recover from faults or give you better performance in real time. And so most of my work has been funded by NASA. I currently have a project right now where I'm building a computer that's going to go to the moon in 2022. I've got we actually have this computer that we've invented called RADPC that uses an FPGA and can react to ionizing radiation that causes a normal computer to crash. And so we've developed this computer and we're going to fly it, or we actually have 2 small satellites in orbit. One of them is called RadSat-U. This is a picture of it right here. This is its launch back in November of 2019. I'm standing in this crowd right here with my students watching that go off from Wallops Flight Facility. Here's a picture of it being pushed out of the International Space Station, so it's in orbit right now. We have a second satellite that's up there called RadSat-G, and these things are about the size of a loaf of bread. Here's its pictures of it. It's launched at night, being pushed off the International Space Station again. And then we do all sorts of other things like balloon flights to try to test this computer in various environments. We've had it on the International Space Station. Here's a version of this computer, RadPC, being installed by an astronaut. And then we've done everything from flying on sounding rockets to weather balloons. And so anything and everything to just kind of test that technology. So what my background brings is I have a degree, a PhD in electrical and computer engineering. I've also worked in industry using this stuff. And then I also do research that really takes what I'm about to teach you and actually implements it in applications that can kind of advance computing technology.
Okay, so let's look at how you actually engage in the course. So everything in this course is going to go through our course management system or the website, which is called Brightspace. And you get to it by going to ecat.montana.edu, and it'll redirect you to ECAT 1 or ECAT 2 or whatever. But when you jump in here, what you're going to see is your main entrance point to all the courses that you're registered for at Montana State. And if you go down here to the bottom right, you're going to see the active courses. So click on Microprocessor, Hardware and Software, and here you are. So you've got, when you first come here, you're going to see an announcement. And we'll post these announcements every week to kind of give you a reminder of what you're going to work on. This is the same stuff that's in the syllabus, but it'll just be a little reminder. And you can see the board we're going to use, a little 3D image there. And this one, we list out specifically what assignments are going to be due this week and the following week. So during the first week of class, I want you to do a couple assignments so that I know you're logged into the system. But then after that, everything will be due the following Wednesday at noon. Okay, and we'll look at that when we get to the syllabus. Okay, all right. So you got this website right here, and everything up here at the top are all the tools that you're going to use. But you have content is where everything is. So grades are going to be where you look at your grades. But content, I have a page for every module that we're going to cover. So things like quizzes and assignments, you don't really need to go in there unless you just want to see them all at a glance. But basically, I'll have links to the quizzes, links to the assignments when you go into content. So let's go into content. And here we go. So here's your course information and syllabus. And then I have a page for every module we're going to cover. So we're going to cover 15 modules, which correspond to every chapter in the book. So we're going to walk through that book from page 1 till the end, and you're going to understand everything there is in that book. And then at the end, we'll do a final project, which brings everything together. So let's start with course information and syllabus to try to go over the logistics first. Okay, so here we go. Another cool picture. So here's kind of the information for the course. Link to a syllabus, link to the course overview video that you're watching right now. This is my voice is back enough so that I can actually talk. At least you can kind of hear me. I'm really close to the mic right now. And then after you listen to this overview and read the syllabus, I have a course overview quiz. So just a way to kind of like show you how to take a quiz, low stakes. It is graded, but it'll get you moving here. Okay, so here's the here's the contact information. So you got myself and Charlie. Okay, so I'm the instructor, Charlie's the teaching assistant, but you want to talk to Charlie, okay, because Charlie's going to be the one grading. So you always want to be in contact with Charlie. He's also going to be the person that helps you answer homework, answer questions on homework and labs. And we communicate via email. So that's our primary mode. I don't even know if phones work anymore. So just email us. Here's our email information. And then if you want to do a video call, we have these WebEx personal rooms. So this is mine right here. And then this is the, Charlie's right over here. And what you do is if you want to do a video call, you just email and set up a time with Charlie or myself, and then we do a video call. And this is how we can help you debug your code or debug your circuitry. And it's pretty amazing how well this works. I didn't think it was going to work that well, 10 years ago when I started doing this. And it actually works well. You'd be amazed at sharing your screen, looking at your source code, pointing your camera down at your board and seeing what's going on. It's amazing how easy it is to help you, and I've seen it work just as well as if Charlie is standing right next to you. Okay, so since email is our preferred mode of communication, I have a little guide here on professional email etiquette. Okay, so some of the emails we get are pretty atrocious, and don't tell me who the student is, don't tell me what class they're in. And so I'm like, well, I'll just write a little guide for you. And so I read through this guide. It kind of shows you how we want your emails to look. And if you do that and do the little activity at the end, you can actually get 20 extra credit points. Okay, a 2% bump to your grade. So go ahead and do that. All right, required material: computer with high-speed internet. This software is one of the few engineering tools that does run on a Mac. Okay, so if you have a Windows machine, Mac, or Linux, it actually does work. Okay, it's one of the few things that works on a Mac. Okay, gotta get the textbook. You want to get the textbook, you want to buy it right here. Don't go to the bookstore. The bookstore is always more expensive. Do it through Amazon. If you're a college student, you get free shipping and all that sort of stuff. It's a great book, gotta tell you. I've met the author. So you also need a portable lab kit. If you're reading this and if you're watching this video and you don't have your kit, you need to get it right now, because you cannot do anything in the class without the kit. Everything is about the labs. Okay, so the labs are worth the most points. It's what you're going to spend all your time on. You're just going to be coding and downloading onto this little microcontroller and blinking things and spinning motors, and it's awesome. But you got to have it. Okay, so either get to the ECE office per my prior emails, pick it up, or email me immediately so that we can ship you the kit. We need your address. And then you're going to have you need a camera, right? So basically a smartphone. So you're going to take little videos of your board, flashing lights, where you push buttons, etc. That's how you're going to demo the labs, in addition to uploading your source code. Okay? So those are the materials. So now let's look at the logistics in a little bit more detail. So I'm going to come into the syllabus. And the syllabus is really where you want to be spending. Every time you log into the course, you want to mess around with the syllabus, because it's going to show you the schedule. And I'll show you that just in a second, but let's just go through and make sure that you see everything. Okay, description of the course, already did it. Learning outcomes. It's important to know that we don't ever do anything in my classes without it being tied to a learning outcome. We don't just do it because it's fun. We always are trying to achieve some learning outcome. So, every module has a learning outcome, except the intro. Except for actually chapter 2, it does have learning outcomes. But this course focuses on 14 specific learning outcomes. Contact information, already covered it. 12-week summer session. It starts on May 10th, runs through the end of July. And I have deadlines every week. If you want to work ahead, go for it. If you just want to crank some Red Bull and do this in a couple weeks, that's fine with me too. You can work ahead. You just can't work behind, okay? Access to the equipment that you need, we already covered it. Prerequisite, you have to have logic circuits. So you can't come into this class and not know what an AND gate is. Okay, you can't come in here and not have an idea of what memory is. We're also going to be programming in C in the second half of the course. So you got to have, this can't be your first C programming class. If it is, you might be able to review enough to do it. And I do give you a little review in chapter 13. But you really need to ramp up on C if you haven't covered it. We're not going to do anything crazy. We're not doing pointers or anything. But you need to know basic program construction, what a main loop is, what loops are, or how you do bit banging and stuff like that. Okay, course website, blah, blah, blah. Office hours. We don't have office hours. We're just always here. Okay, this is all virtual. So you email us wherever we are on the planet. We'll get back to you within 24 hours. But it's important. Always email Charlie, okay? I want you to email both of us, but for some reason that seems hard. But make sure Charlie's your number one guy, and then put me as a copy. Okay, if you email me on something about grading, I'm going to immediately just forward it to Charlie and say, Charlie, handle this. All right, grading. Check this out. Labs are worth 600 points. There's 1,000 points possible in the course. Okay, so 600 points are labs, and 100 points is the project, which is just another big lab. So you're basically talking about 70% of the class is a lab, and that's the way it should be. Because this is a skills-based course. You're learning how to program a microcontroller, and you only learn that by programming a microcontroller. You don't read about it or look at somebody writing on a whiteboard. You program a chip. So that's what we're going to do over and over. However, every single section that we go through, I have a small homework problem just to make sure that you did it. Okay, because what happens is if you try to jump into the code before you actually go through the background material, it sucks because you don't know what you're doing, and so you're just guessing and typing in crap. And then we have to help you, and it always ends up happening where we just say, did you read the book or did you watch the videos? And you're like, nope. It's like, well, do that first. It's going to save you time. So we have accountability homework here. They're really easy. Grading, straight grading. 90 is an A, 80 is a B. I don't give minuses because that dang A plus, right? If you get a 90% in a class, it can be an A minus, and you lose points off your GPA. It's like a 3.7 count. Well, if I get a 99%, I don't get a 4.3. So I think that the plus minus system is not that great. So I don't give them. Of course, I reserve the right if I want to. So I have to have that in there. Passing grade in the lab, 70%. Obviously, you can't pass this course without passing the lab because this is the lab. Academic policies, don't cheat. What's the difference between cheating and collaborating? Collaborating is the way engineering is done. Okay, you work with other people. You share ideas. If you're working in a group of, let's say, 3 or 4 people, and you're all coding and you're asking questions of each other, looking at how things were done, that's engineering. That's how it's supposed to be done. Cheating is where you turn in somebody else's work. Okay, so if you just don't understand what's going on, you say, "Can you give me your code? I'm going to upload it," or you take a video of their hardware. That's cheating. So we want you to collaborate, but we don't want you to turn in other people's work. All right, what do we do in this course? Read. I wrote this book. Read it. So we're going to read every line in here. The way that this course was actually developed is we came up with the structure of a course like 2 years ago. So we have this huge focus group of students and faculty and industry people. Came up with the perfect course. Like, what do you want the course to be? And it was basically a very lab-intensive course where the labs are very short. So we do a lot of short labs. You're going to be doing like 20 or 30 short labs, okay? Instead of like, hey, it's week 2. We're going to do a 2-hour lab because we have 2 hours in the room. It's like, no. You do short labs, you learn a lot, you do a lot of assignments. Then I wrote the book. So the book basically describes everything that we teach in the course. And then I recorded the videos over the book. Okay, so the reading and the videos are actually the same thing. It's just that some people like to read, some people like to watch videos, some people like to watch videos and have a reference. Okay, the book is great because you have tons and tons of example code. So you can look at how I coded these things, and all the code in the book it runs. Okay, so I mean, like, I typed that stuff into the compiler and ran it, and then I pasted it into the book. So it's not just like I think it's going to work. Homework. Every section of the book has a multiple choice quiz homework that just shows that you read the stuff or watched the video. Lab assignments. You're going to have a whole lot of lab assignments, and you're going to use a video to demo them. So short videos, like, we'll look at this, here you go. And I'll also upload your source code each time. Then we're going to have a final project that's worth 10% of your grade, where you get to kind of do an open-ended project, define what you want to do, use multiple peripherals. If you don't know what a peripheral is, you will. And so that's basically the entire course. This right here is where you want to look every single time you engage with the class. So if you say, I'm going to work on this class today, this is the first thing you want to look at. This is the schedule, and it's also the graded deliverables. It's what you're going to work on, how they're graded, how much they're worth, and when they're due. So week 1. In week 1, like I said, I have 2 deliverables that I want you to do by Wednesday at noon. Okay, and that's to prove to me that you're logged into the system and you're engaged in the class. Then I have a bunch of deliverables that are due the following Wednesday at noon. After we get through week 1, every week is the same. You come in here, you look at what's due, and it's all the activities are due the following Wednesday at noon. So every week, the following Wednesday at noon, the following Wednesday at noon, following Wednesday at noon. And we get in a pattern, okay? And the reason I do the following Wednesday is it does give you the weekend to work on it. It gives you a little bit more extra time there, and then maybe you have some questions after the weekend. So I just came up with this Wednesday at noon deadline. Notice that there's a whole lot of assignments that aren't worth a ton, but you will notice one thing. The homeworks aren't worth a ton, but the labs are, okay? And that's why it's important, right? That's how we learn. We learn in the labs. And you'll notice that not every module we work through has a lab. So some of the ones don't have a lab, like Module 3 doesn't, Module 4 doesn't. But then once you get into Module 5, they all start having labs, and many have multiple labs. In fact, most have multiple labs. So you'll notice over here in this column, lots and lots of labs that you're going to do. And they're worth a lot of points, okay? Each module also doesn't take a week, okay? So some take more than a week, some take less than a week. In week 1, you're going to cover 3 modules. In week 2, you're going to cover 2. Week 3, you'll cover 1. And then you kind of get into a flow where it's like 1 module per week. Week 6, you have 3. So you got to know what you're working on each week and what's graded and when it's due, and that's why you always come to this document right here, okay? Okay, we keep going. I mean, 7, 8, 9, 10, 11. You get to week 12, and that's the final project. Okay. The only deadline that's not due on Wednesday at noon is the last week of the class, and I put it on the last day of class, Friday at noon. Okay. So lots and lots of points, a lot of low stakes. Okay. So it's not like you have one exam that makes or breaks your entire class, right? It's if you just do all the work and continue cranking along on here, you'll be fine. Okay, so now you're sitting there going, okay, I know what is due, I know what activities exist, and I know what to do. Where do I find the material? All right, so that's where you go back to the course. Let's go to content. So I come to content, and let's look at Module 1. Module 1, this is a typical content page. Every module has a page. I always start off with the learning outcome. Why are you doing what you're about to do? Then you get into the activities. You'll notice that under the activities, you have a section and a lab. Okay, so this is Module 1. There's only one section in the book on this one. It's a pretty short chapter, just a couple pages. And there's activities. So what are the activities? Well, read Chapter 1, watch this video. Same information in both, just a reading versus a video. And then do something. And the do is a multiple choice quiz. So if you click on that, you're going to see the quiz. Okay, so mine's a little bit different than yours, but you're going to have this multiple choice questions that you can answer easily after you've read the material or watched the video. If you click on the video, you're going to get a little YouTuber here. So let's see. Yeah, so you got the YouTube here. You know, watch a video. Watch an ad. It ain't going to hurt anybody. But let's see what they look like. Good Lord. So I'm going to skip the ads, and then here I am again. And it's just me talking, just kind of describing the same information that's in the book. Yeah, that's it. Subscribe to my channel, all that sort of stuff. All right, life is good. Now, here's a lab. Okay, so I come over here and I read the lab description, and you finally have something that you're going to do. The first lab is just to install the software and run a program that we give you. So the software we use is called Code Composer Studio, and it's from Texas Instruments, and it's awesome. Okay, you install this thing, you type it in, you write code in assembly or C. If you don't know what assembly is, you will. Don't worry about that. And it shows you how to like attach the board, target a particular board. Our processor we're going to use is called the MSP430, and then you compile it, download it to the board, and you're off and running. And so I give you the code for this, and that's what a lab looks like. Then you take a little video of it, you know, blinking in this first one, and then you upload that video to the assignment folder. Again, if you click right there, it takes you to the assignment folder that you upload to. Some Q&A on the first couple modules, but let's look at another module. Let's click on the next arrow, and we go to Module 2. Here's another module that should have a similar layout, right? Learning outcomes, here's what you're going to learn, and then you go through the activities. Again, it's like read, watch some videos, read, watch some videos, read, watch some videos, read, watch some videos. This one, Module 2, looks like a ton of work. And the reason it looks like a ton of work is because this is just a review of the prereq material. You should know all this stuff. And so you should be able to, what I would do if I was you is I would just open the quiz right away, and I would look at the questions, and you should be able to answer them. And if you don't know how to answer them, just go back and watch the video or read the sections in the textbook. Chapter 2 is like an entire course because it really is. That was the prereq of logic circuits that you should have taken before you came into this course. So next one, Module 3. Now we're getting into like the flow. Okay, so now we're starting to talk about new stuff. So here we go. Learning outcomes, learning activities. We got section 3.1. Read, watch a video, do a quiz. Read, watch a video, do a quiz. Read, watch a video, do a quiz. Quizzes and homework. Okay, no lab in that one. So then you notice here's Module 4. Kind of the same thing, right? It's always the same. Okay, finally we get to Module 5. You finally get to some labs, and now you start seeing it's like section 5.1, 5.2, 5.3 lab. Oh, okay, that's cool. And then you start getting to where you start having a lot of labs. So it's like, okay, section 6.1, 6.2, 6.3, lab. 6.4, 6.5, 6.6, lab. 6.7, lab. And so as you get more and more sections under your belt and you know enough to do a lab, then we have a lab. And so that's what the flow of the class is. Now, this is the content, right? So this is the content laid out in a content-oriented fashion, meaning that each module has a page. What you do in terms of how fast you work through them, whether it takes 1 week, a half a week, a third of a week, or 3 weeks, that information comes from the syllabus. So that's why you're always sitting over here looking at this syllabus to make sure you know what you're working on that week and when it is due. So that's going to be your best buddy. And you just flick through all these and you learn all this stuff. It's awesome. And then the last one is going to be the final project where you get to actually define something on your own, hook some stuff up, and do it. Okay, that is the overview of the course, me, the logistics, and how you engage in the material. Okay, so I look forward to working with you this summer, and good luck.